So one of the first things we're going to be doing is some solving with logarithms. So let's start with something simple, and the natural log of x is 3.4. And let's just review converting a logarithm into an exponential, remembering that a natural log has a base e right there. So the first thing I would do is turn this into an exponential. E to the 3.4 power equals x. Remember, I was using my start with the base, loop and swirl method. And then all you do is you put this in your calculator and you figure out that x equals 29.96. I'm going to try that one more time. Natural log of x equals 1/2. Remembering that there's a base e right there, starting with your base, using the loop and swirl, you would say that e to the 1/2 power equals x. And then you can just put your e to the 1/2 power in your calculator, and you'll know that x equals 1.65. So let's change that up, and we'll do 10 to the x power equals 18.197. So now we have base 10, and we're going to turn that into a log. So remember that the base goes down low, and we're going to start with our base, and we're going to use the loop and swirl method. So we put our base down low, then we put our 18.197 equals x. So base 10 is what goes directly into our calculator, so we stick that in our calculator, and we get 1.26. I'm going to show that one more time. 10 to the x power is 0.024. Turning this into a log, starting with the base, looping and swirling. The base goes here, down low, and then the 0.024 would go here, swirling back to get the x. This can go directly in the calculator because it's base 10. You know, turning x into something that's a decimal or a fraction would be a negative exponent, 1.62. So those are basic, just showing you the conversion. So let's do something a little bit more complicated. Let's use an e. There. So now, first thing we want to do is try to isolate this e here before we can do our loop and swirl. So I'm going to subtract this 2, and I'll have negative 3 e to the 0.4x power is negative 9. Then I'm going to divide by negative 3. E to the 0.4x power is 3. And now that I have my base by itself, I'm going to put this into a natural log. I'm going to put my base down low. I'm going to loop and swirl. So 3 would be next, and 0.4x would be right there. The last thing that I do is I divide by 0.4. Now when you're a natural log, this e here is understood. We don't really need to write it. My final answer is natural log of 3 divided by 0.4. Now, this is what we call the exact answer. If you're asked for a decimal approximation, 2.746 in your calculator. On your exam, you'll be asked for exact answers. Okay. So there's an example of one where you have to convert to logarithms. Let's do one that's exponential. So the first thing I'm going to do is add my 228. Let's make 0. Excuse me. Which leaves me a 78. Now that my base is alone, I'm going to start with my base. I'm going to loop and swirl. So I'm going to use a log, base 10, 78 equals x plus 5. Now again, on a basic log, this 10 is understood, and the next step is to subtract 5. So that'll be log of 78, then minus 5. And that's your exact answer. Okay. My decimal approximation would be negative 3.108. Let's try another one. So first I'm going to add my 8 here. Excuse me, I'm not going to add my 7. Subtract my 7. Pardon me. There, see that? So I have negative 22 here. Then I'm going to divide by my 8. Which leaves me 2.75. So remember, there's a little imaginary E right there. And I'm ready to loop and swirl. So I'm going to go E to the 2.75 power equals 3x. And my last step is to divide by 3. So the exact answer is E to the 2.75 power divided by 3. Which you could also write 1/3 E to the 2.75 power. Those are both exact answers. If you wanted a decimal approximation, 5.214, putting that in the calculator. Let's solve one more before we change topics here. Let's do a log. So first thing I'm going to do is add my 4, which leaves me 2.5. Then I'm going to divide by 2, which leaves me 1.25. So remember, there's a little 10 right there. And I'll do my conversion. 10 to the 1.25 power is 5 minus x. The next step is to subtract the 5 and then the next step is to multiply by -1. So x will equal negative 10 to the, oh, sorry, don't want that, 1.25 power plus 5. And the decimal approximation should be negative 12.7828. So that's one topic that's covered in section 4.4. Another topic that they cover in 4.4 is expanding and condensing. So basically we're taking our rules of logarithms, our product rule, our quotient rule, and our power rule. And we're using them to put logarithms together and to pull them apart. Okay? So let me just remind you of the 3 rules. If I have log x plus log y, I can put them together into x times y. If I have log x minus log y, I can put them together into a single log by dividing them. That's our quotient rule. So addition goes together with multiplication, subtraction, division. And these rules come straight from, if I was multiplying like bases, like that, wouldn't I add my exponents? That comes straight from this product rule. And if I was dividing, like bases, so when I'm dividing like bases, like that, don't I subtract the exponents? And that comes straight from the quotient rule right there. The last one is if I have a log like that and it's been powered, I can take that power and put it out front like a multiplier. And that comes straight from, if you have a base powered to another power, that you basically just multiply those powers. So that's that rule right there. So these 3 rules here that we use comes straight from our exponent rules. So the second part of this section is really kind of easy. It's basically, they'll give you some logarithms. Like, for example, they might say, take the natural log of 2x and add it to the natural log of x minus 7. Condense that, they might say. Well, since it's addition, you would just say, I'm just going to take 2x and multiply it by x minus 7. And you might go one step further and call that 2x squared minus 14x. Or you might get something like, take the natural log of x and subtract it from the natural log of x minus 1. Condense that. Condense means to write it as a single log. And you'll see, well, it's subtraction, so I'm going to divide those two things. Well, with this one, that's all you can do there. However, what if I gave you this one, x squared minus 9, and then x plus 3? So you see that that one's subtraction. So when you put the x squared minus 9 on top and the x plus 3 on the bottom, like that, hopefully you remember that x squared minus 9 factors to x plus 3, x minus 3, and these are common factors, which leaves you x minus 3. So a little fun right there. You might be given something like m squared n, and they might ask you to expand that. Well, that's a multiplication problem. So first you'll take your m squared and your n and make it an addition problem, because multiplication is addition. But then the last thing you'll see is this exponent. Remember, that's your third rule, that power rule, and it should come out here and be a multiplier. So your final answer will be 2 log m plus log n. So we're going to expand this one, and you might be looking here and saying, oh no, what's that? So remember, we're working in exponents. So first of all, we need to say, well, what is that exponent? Well, that exponent means 1/3. So first I'm going to get rid of that radical and make it an exponent. Now I'm going to start expanding. So I'm going to have my p to the 1/3. Q is a multiplier, so I'm going to add q. And x is a divider, so I'm going to subtract. And I made them each their own logarithm. So you saw x was in the denominator, so it's negative. But the last thing I have to do is take care of this exponent and turn it into a multiplier. That's my power rule. And that's expanding and condensing. The last thing that they talk about in this section, and we talked about having 10 as your base, and putting this in your calculator, you can just put that straight in your calculator because it's base 10. If you have a base, let's say that's 5, and you cannot put that in your calculator, you have to use your change of base. Change of base just means to do log of 3 and divide by log of 5. So notice that this was on top, oopsie log, and your base is always on the bottom. So if you need a formula for that, log B of A, it would be log of A divided by log of B. Notice your base is always on the bottom. And that's how you would calculate a logarithm that's not in base 10. Okay, let's try solving another problem here where we use some condensing. So the first thing I'm going to do is add this log to the other side. So when I add these two logs together, really what I'm doing is multiplying. So I get 2x squared plus x. Good. Remember that's base 10. So I'm going to loop and swirl here. So I'm going to get 10 to the first power is 2x squared plus x. Looks like I have a quadratic. So to solve this one, I'm going to move my 10 to the other side. And I'm going to factor this one. So I'm trying to make a 20 here. I'm going to have to use a plus 5 and a negative 2. So it looks like my values are going to be negative 5 halves and 2. Now, remember we learned about logarithms. Negative numbers in a logarithm are extraneous. Okay, can't have negatives. So this is my only good answer. Remember, you can't have negative numbers in a logarithm. We said before on the domain, it had to be greater than or equal to, actually, couldn't even be equal to, greater than 0. Let's try that one more time. So we can do log x minus 1 is negative log of x minus 9. So I think I'm going to add my log x minus 9. So I can multiply those. So I have x squared minus 9x minus 1. And then I can just add my 1 to the right side. Then remember, this is a base 10. So I will have 10 to the first power is x squared minus 9x. I'm going to subtract my 10 to the other side and factor. So my values are 10 and -1. Again, this is my extraneous solution, so 10 is my only answer. -1 is not going to fit into this logarithm up here. So here's another type of problem that I think we should take a look at. This is probably one of the harder problems because you can't really take there's different bases on both sides. So we're going to start this one by taking the log of both sides. And we're going to use the power rule on this one, which means that we can take our coefficients, our exponents, and make them coefficients. Like that. So I'm going to distribute, remember these are just values here. I'm going to distribute this into my parentheses. Remember, we're solving for x here. So I have an x term here and an x term here. I'm going to get those on the same side. So I'm going to subtract this one over here. So I'm going to have x log 7 minus 2x log 4. So I need the x out of those two terms. So I'm going to factor the x out of those two terms, which will leave log 7 and 2 log 4. Now that I've taken the variable out, this is basically here just a coefficient of x. It's just a number, okay? So I'm going to divide it away. So now it's been divided away, and x is by itself, which is what I wanted. And over here, -1 log 4 divided by log 7 minus 2 log 4 is the exact answer for this problem. Now, if you want to turn that to a decimal, 1.676. But usually this is the preferred answer. Okay, let's try that one more time, because I know you're probably thinking, oh no, what just happened? Okay, let's just try that one more time. So, when you have different bases on both sides, you have to start by taking the log, or the natural log, it doesn't matter, of both sides. That allows you to take these exponents out of the exponent spot. So now I can put the x plus 1 here and the x here. So now they're coefficients. So now I'm going to get rid of parentheses by using distributive property. And now I'm going to get my x terms on the same side of the equation. There. So that'll be gone. I can drop the 1. Log 2 equals x log 3 minus x log 2. So I'm trying to solve for x. So you see my 2x's right here? I'm going to factor it out of both of those terms, and you'll be left with log 3 minus log 2. So basically this right here is the coefficient of x. So my next step will be to divide it away from both sides of the equation. This side it will divide away and leave x. This side will be left with log 2 divided by log 3 minus log 2. This is considered the exact answer, and you would be done. Or you could put it in your calculator, and you could get a final answer of 1.709. If you just had something simple, like, let's say this one, you don't have to do log of both sides because you can see you only have one base. You can just say, okay, I'm going to do log base 5 of 128,965 equals 3x minus 2. And remember, I showed you how to put this in your calculator. You do log of 128,965 divided by log of 5. That change of base formula that I talked to you about, which turns out to be 7.3114. Then you add 2, 9.3114. And then you divide by 3. 3.104. And that's a good recap of section 4.4.